Mars is our neighboring planet and the first planet humans will step foot on other than Earth. This makes it important to learn as much as we can about Mars. My name is Ivan Mishev, and together with Professor Isaac Smith, we have been working on characterizing and mapping light-toned layered deposits on the plateaus of Western Valles Marineris with SHARAD radar and high-resolution imagery. Valles Marineris is a giant canyon system near the equator on Mars. It's so large that if it was on Earth, it would stretch across the entire United States. And on this massive canyon system, we have observed light-toned layered deposits, which are areas on the plateaus that appear to have been hydrated, altered, and reworked into these layered formations. The main plateaus I've explored are near Ekis Chasma and the northern and southern plateaus of Ias Chasma. Characterizing these hydrated layered deposits is essential to testing the hypothesis of their formation and may constrain the timing and duration of water activity in this region. Until now, these light-toned deposits were only observed with imagery, but in this project, we used the Mars Shallow Radar, SHARAD, on the Mars Reconnaissance Orbiter to create a map of all the basal reflections observed on the plateaus. Using SHARAD radar data, such as these 3 radargrams showing Ekis and Ias Plateau, and geophysical software, I examined hundreds of radar tracks and all the true reflections were denoted. To ensure what reflections we observed were accurate, simulations of the radar data were made using the land topography. These simulations would reveal any clutter, which are false reflections in the radar data due to rough off-nadir topography. The results are shown here with a map of all the locations that basal reflections are shown. Starting with the thermal image of Western Valles Marineris, a large amount of reflections were seen on all 3 plateaus. Ekis Plateau had a huge concentration between a graben and the canyon rim. Looking at North and South Ias, it's observed that large concentrations are on the eastern region with a small gap and another concentrations of reflections further west. The next step we took was to look through high-resolution imagery, namely HiRise and CTX, which are instruments that are also on the Mars Reconnaissance Orbiter. Looking through these images, we see some of the beautiful widespread layering located on these plateaus. There are also areas such as this that have more isolated occasional layering, and there are also regions that have no layers, but due to the large amount of radar reflections, this indicates some type of massive unit of material there. Going through all the imagery, all of the areas where layers were located were identified and a comprehensive map was produced. This final map shows the areas with widespread layering in orange, the massive units that have occasional, more isolated layering in green, and the layerless massive unit in yellow. We expect that the widespread layered region formed due to pooling of water or lake deposition, analogous to lacustrine sedimentation on Earth, and the areas with occasional layering would have far less water. The massive unit in yellow would be regions that were absent of water. When looking at the radar reflections imposed on this map, we can see that the area with widespread layers have ubiquitous reflections. These radar reflections were used to constrain the boundaries of all 3 of these regions. With the characterization complete, future work with Professor Smith will go into testing the hypothesis of the light-toned layered deposit formation. They are thought to be composed of pyroclastic ash that was in place during volcanic eruptions from the nearby massive volcanoes, which was then altered with water by sedimentary deposition. The fully mapped plateaus give larger context to the geology of Valles Marineris, providing insight into the geological history and water cycle of past Mars climate states. Thank you very much for watching, and thank you Lassonde and York University.